Hi everyone, how are you? Today we would be going to learn about Terraform and let's start off. So video would be comprising of why we need Terraform. We would be covering a brief of Terraform introduction and the workflow related to Terraform. The major problem when we are creating a distributed systems is about the consistency and the predictability of the environments which we create. So someone had a thought on this and they created Terraform, and that's how we are provisioning infrastructure through software so that we can deliver consistency and predictability in the environment in which we deploy. So now let's see what are the properties of infrastructure as a code or when we are provisioning resources using code. So the first one is imperative. So let's see if we need to create a coffee using infrastructure as a code, we would be using this index where we have a keyword coffee and the category is drinks and the ingredients we need to specify as hot sugar, what would not, sugar, instant coffee, and the spices. So if we give this to an infrastructure as a code, it would be creating a coffee with the ingredients which were specified. So it's imperative in nature. Infrastructure as a code is idempotent in nature. So let's take an example here. Here in left we have Alex and in the right side we have our Terraform. So let's say Alex wants to make a coffee and Alex asks make a coffee for me to Terraform, and Terraform would be creating that coffee and giving it to Alex, and Alex says he needs a coffee after some time. So Terraform thinks of it and sees the logs or the state and see that Alex has already requested coffee and would say that I have already given the coffee and you already have it. This is what Terraform is, and it's idempotent, meaning it has a state and it has logs of what it has done in the past. So the benefits of infrastructure as a code or Terraform is its automated deployment. So the resources which we create in Azure or GCP will be automatically provisioned and it would be consistent in environment because we are writing the code and we need to provide those properties correctly so that consistency would be there on all the things which we create, and it's a repeatable process. The last benefit of it is documented architecture. We would be documenting everything in a version control system as we are writing the code, and we would be deploying it using Terraform. So now let's see what are the Terraform project structure looks like. So in a working directory, we would be creating a bunch of .tf files, which is an extension which Terraform understands, and all the files will be read by Terraform. We can name it as main.tf, providers.tf, backend.tf, anything is fine. The naming convention doesn't matter there, but the code which we write should be according to what Terraform document says, and those should be like block or resources block and data store block, etc. So here the providers is the cloud which we be using. There are a lot of providers available. Some examples are we would be able to create resources or infrastructure using AWS, Azure, GCP, vSphere, etc. And Terraform, as I said before, Terraform has a log of what it does. And how does it do? It is using state objects. It creates a .terraform file in the directory and stores it in .tf state file. So this is an example of .terraform file written in JSON format. So we have both options of writing it in .tf and also .json format. Here we are using .json, where we are providing the provider block. So here we are specifying which cloud we need to use, and this is an on-prem cloud. We would be able to create vSphere cloud, and here we are specifying the credentials which Terraform needs to use when they need to create the resources. And in the resources block, we need to specify what resource we need to create. Here it's vSphere virtual machine, and this is the name of the machine which we create and the properties associated with it. The documentation to each of the resources would be there in the documentation in the Terraform website, and you would be able to search for each and every infrastructure which we need to create in different providers. Let's say if we need to create Azure VM, we need to provide the Azure provider here, and the password and the service account or anything which we need to specify here. And then we need to create a resource which is Azure's virtual machines key. Now let's see how the workflow of Terraform is there. So first we write the code. So we write what are the resources or infrastructure we need to create. And then what we do is we initialize Terraform in the directory, so that Terraform would be able to download all the resources needed for the specific provider. And then we use Terraform space plan command. At that time, Terraform would be contacting the cloud providers using APIs, and will check what are the things which we need to create and what are the changes need to be done in the infrastructure to create that resources, and it will show the full plan, what to create, what to change, and what to delete. After that, if we are okay with the plan after the review, we can create the resources using Terraform space apply command, after which it would be going to the provider and creating the resources which we wrote. If we don't want that to be happening and we need to delete everything which we created, we can use Terraform destroy, but it's not good to use Terraform destroy. So now let's see the overview of an enterprise level Terraform application. So here, when we are working as a team, we need to share the things. So in Terraform also, we need to have a main repository or a main place where we need to save everything which we created in different set of providers or cloud providers. Let's say example of an AWS, VMware, or GCP VMs which we create. We need to have all the logs or the state files maintained in a centralized repository. That's how Terraform Cloud comes into the picture. And through Terraform Cloud only, we would be creating the resources or deleting the resources or changing it. And we would be writing all the code in version control system, so that we make all the resources documented, or we if we need to revert it or look upon the commits earlier, we can do it. And private modules, we can make use of private modules in an enterprise level. If we need to have custom modules, let's say example, if we need to create a Kubernetes cluster with a specific credentials, we would be able to create private modules and pass it on Terraform Cloud and reuse it every time.